Good evening. I am Siddharth Srivastava.
My name is Bose.
I am Vidushi Goyal.
My name is Aditya Agarwal.
We are at Electronic Hobby Hub at IIT Kharagpur. Our team ID is 30.4 and our paper number is 594 entitled Gait Analysis using MEMS based sensors. The main motivation behind this project is that today's gait analysis technology is limited by the use of cameras at different angles and directions. Due to this, today's gait analysis can only be done in labs or at specific rooms. Our aim is to make this process more user-friendly and more remotely accessible, just like any other biomedical system on today's market. For that, we propose a new system wherein the gait can be analyzed using an accelerometer and the data can be sent via Bluetooth to any Android phone app. We will now give you a brief listing of the components that we are using for this project. The first component that we are using is the accelerometer ADXL335 from Analog Devices. The next component is an active filter which we have created by using INA 106 op-amp from Texas Instruments. The next block is an analog to digital converter for which we have used ADC 0809 from Texas Instruments. For the purpose of our processing, we have used two boards. The first one is an Arduino board with an Atmega 328 IC, and the second one is an MSP 430 G2553 Texas Instruments Launchpad. The final electronic module that we are using is the Bluetooth module from SparkFun, which will send the data to our Android app. The first block that we are using is the accelerometer. In the accelerometer, the sensitivity of the meter is 312 millivolts per G. This accelerometer is tied to the foot of the person whose gait we are analyzing. Once he starts walking, his foot deviates from the mean, and as the angle changes, the acceleration value changes, which causes a change in the voltage, and this data is recorded for further processing. Before sending it to the controller boards, we have two blocks. The first one is the active filter. The purpose of the active filter is to act as a low-pass filter in order to reduce noise, and also to amplify the voltage data coming in from the meter so that we can increase the resolution of our system. This analog data is now passed on to an analog to digital converter. The IC that we have used, ADC 0809, is an 8-bit parallel IDC. This data is sent to the microcontroller boards for further processing. The first board, which is the Arduino board, is used for acquiring the data and for calculating the local peaks at the minima. While the calculation of peaks can be done for both max and minima, for our project we have limited the scope to using only the minima data. Once the data of the minima has been processed, it is sent to the MSP 430 Launchpad board, wherein the actual gait parameters have been calculated. For the purpose of our project, we are calculating only two gait parameters as of now, the cycle length and the deviation from the mean, which can be used to calculate the stride length. Once the data has been calculated, we shall send it to an Android app via a Bluetooth module. In the Android app, we shall connect to the Bluetooth module. In the Android app, we shall connect to the Bluetooth module, and once we are connected to the device, we shall send a signal. Once the signal has been sent, the data will be processed, and once the data has been processed, the results will be displayed over here. I shall now send you a short demo of the system. As you can see, we have tied the system to the person's leg and he has started walking. We connect to the Bluetooth device. Once the device is connected, we send a signal to the module in order to tell it to start processing. The processing has begun, and once the data is collected, the result should be displayed on the screen. As you can see, the cycle time and the deviation both have been displayed. The cycle time, as you can see, is 1.82 seconds, and the deviation from the mean is around 49.69 degrees.
By benchmarks, the cycle time should be around 2 to 3 seconds as per many papers stated in biomedical fields.
Thank you. Thank you.
Thank you.
Thank you.